Let's talk about heat capacity. Heat capacity refers to the amount of energy required to raise 1 gram of a substance by 1 degree Celsius. Heat capacity is an important chemical process. For example, when you bite into a pizza, the cheese remains much hotter than the bread for longer because the cheese has a higher heat capacity than the bread. The energy used in heat capacity is just like energy used to move objects. For example, if a person pushes a 10 kilogram box at 10 meters per second, then the energy to do that is 500 joules. Heat energy is also measured in joules. Let's take this question for example. Determine the amount of energy in joules needed to warm 237 grams of water from 0 degrees Celsius to 80 degrees Celsius. We can use the concept of heat capacity and energy in joules to determine the answer to this question. The molar heat capacity of water is 75.3 joules per mole degree Celsius. The equation to determine the amount of joules needed to do this is Q equals the specific heat capacity times mass times delta T, where delta T is the change in temperature. Step 1. Convert 237 grams of water into the number of moles of water. We need to do this because we are given the specific heat capacity of water in joules per mole degree Celsius. To do this, you divide the molar mass of water, which in this case will be 18.016 grams. Then, take the final temperature, which in this case is 80 degrees Celsius, and subtract the initial temperature of 0 degrees Celsius. This calculates the change of temperature, or delta T. Now, substitute the relevant values we have obtained into this equation. This gives us Q equals 79,239 joules. Therefore, it takes 7.92 times 10 to the power of 4 joules to raise 237 grams of water from 0 degrees Celsius to 80 degrees Celsius.